Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hoping you are hale and hearty. Summers are already here. Summer has a slow, languorous feel to it, sometimes characterized by tiredness or inactivity. But as nowadays, keeping in view the circumstances, you do not feel compelled to go outside and make the most of the long days in hot sun. You are staying indoors, so rest, recuperate, but remember that every difficulty takes along a hidden opportunity. Assume or imagine it as a time of reflection and renewal. Make the most out of it. Prioritize your daily tasks. Stick to your schedule. When a video conferencing based class would be conducted for live questions and answers session, surely you would be analyzed and scrutinized for what you would have studied or absorbed. So be ready for that. Our today's objective is to study about the modern uses of computers in today's world. Computers are being used in every walk of life since decades, especially in education, in industry relevant to different sectors, in textile industry, in automobile industry, in construction industry, in weapons and missile development industry, and businesses, in homes for personal usage, in weather forecasting, etc. But in recent times, after millennium, some new uses of computers got explored. Due to technological advancements, some modern uses of computers with associated technologies emerged on the horizon. Computer usage introduced the concepts of cloud computing, mobile computing, Internet of Things or IoT computing, and data centers. In today's lecture, we will discuss the concepts of cloud computing and data centers specifically out of 4 types. We will discuss the overview of cloud computing. We'll discuss its services and deployment models. We'll inshallah tell you about the cloud service providers. And later on, we will inshallah discuss the advantages and disadvantages of cloud computing. So, the first and foremost question which should arise in your mind is that, why cloud? What is a cloud? This is the first question to ponder upon, that why a person needs to use a cloud. Nowadays, the amount of data generated online is huge. We know that. Everything is going online these days. We shop online, we order food online, we exchange emails online, we greet one another, we stay in touch online, we socially network or stay interconnected online, we watch movies or dramas or listen to music online. Even nowadays, due to the recent ongoing pandemic, we are teaching online and you are listening and downloading the lectures online. We do everything which is required nowadays online on some type of digital platform, which shows a lot of the data is being generated nowadays by millions of users. So when you have such a huge amount of data, you need to store it somewhere in some storage space. You need a space where after storing the data, you can later on edit, modify or change, or could delete data as per your desire, from where you can again and again retrieve or fetch your data. So in order to store, maintain, manage or process or get your data executed, you would need an online digital platform where you would be able to store your data, but most importantly, whenever you want, you would be able to retrieve your data. You would use the options or services or facilities provided by that online digital platform. All these issues such as cost and monitoring and maintenance and storage space would be taken care by a third party, by a cloud platform, by a cloud service provider. Suppose a customer or user doesn't have enough hard disk space left in his computer. He can't buy another hard disk, neither want to delete his already stored data. So he uses an online cloud platform for storing, maintaining, managing, retrieving his data. For example, that cloud-based platform is Google Drive or Dropbox, where you can save your data for later use too. Cloud is a term used for internet. Cloud platform means internet-based online platform. These cloud-based online platforms are supported, created and provided by many companies. One of them is Google. Google Drive is an online cloud-based platform for storage, actually developed by Google company, where any person in the world can store his data free of cost by creating an account, and an internet connection is essential to access that cloud-based facility. Likewise, Gmail or Yahoo Mail are cloud-based platforms over which you create your email accounts and you use email servers or email services, and that service actually transfers and receives messages or files, etc. Your inbox items or sendbox items are not saved in your computer, rather they get saved into Google or Yahoo Mail servers, email accounts, or in their online storage spaces. In order to access these cloud-based services, you need to have an internet connection and an internet-enabled device and a web browser, commonly Google Chrome or Mozilla Firefox, installed inside it. Additionally, any web or cloud-based apps you use, like such as a drama app or some gaming app or any social networking app, such as Facebook or WhatsApp or Instagram apps, any TV channel apps or for live streaming, YouTube app, music apps like SoundCloud, any health-based apps, educational apps like Khan Academy, etc. Any such kind of internet-based apps are actually cloud apps. And these cloud apps provide certain services or facilities to user through their platform. These cloud apps or cloud-based platforms or cloud-based services are being provided by different companies nowadays. Take another example. When you use, let's suppose, Facebook app on your smartphone, the interface or window of Facebook displaying Facebook options is actually coming from the Facebook cloud service provider. All the data of millions of users using Facebook is being stored in Facebook's server computer. Actually, server computer is a very powerful mainframe or supercomputer which actually controls thousands or millions of interconnected computers around the world. So server is a powerful computer. In order to deal millions or billions of Facebook accounts or millions or billions of users, Facebook uses dozens of servers. Whatever we click, like or comment or send as a post, everything gets stored on Facebook's cloud platform behind the scene on Facebook's servers. Instead of your smartphone or device, your account storage or maintenance of data inside your account, any deletion or addition of data, your Facebook chat messages, everything takes place on that cloud platform instead of your smartphone's platform. Means you are using the resources or options provided by the cloud platform. Some of you might have used Dropbox for storing data online, or cloud applications like Google Forms or Google Slides or Google Documents, or online softwares, online websites or online apps for reading books over the internet to satisfy different purposes. As said earlier, different companies provide these cloud platforms for delivering cloud-based services. Interesting thing is that the whole infrastructure of the cloud provider, including servers, and softwares, the working of these softwares, and the services provided by the cloud platforms, and the cabling, and the routers and modems, etc. Each and everything is invisible to the user. User doesn't know what exists behind the scenes, nor does he concern. He's just concerned with the services he's getting. For example, WhatsApp. Let's take the example of WhatsApp. We don't have view of its infrastructure behind the scenes. We just use the services of WhatsApp, and we are concerned with the quality of the services. We as users do not own that infrastructure. That's a cost saving thing for a person to own, to buy, to purchase, to build the infrastructure behind services. As what would happen if we need to buy a server? Moreover, we don't have any interaction with the cloud service provider. We don't need that interaction, but only in some cases we would need to interact or contact with the cloud service providers for reporting any service issues or any such complaints regarding security or confidentiality. Every day, each user, each organization, each business has to deal with heaps of data, records, and paperwork. It's not just the big corporations, but small businesses too need to keep track of their data. Don't you ever wish that you could carry your data with you all the time without handling and purchasing costly hardware storage devices? And this is where cloud computing steps in. Cloud computing keeps all your information safely stored inside a cloud, an invisible cloud, on an invisible platform. A cloud can also refer to an invisible, remotely placed server over the internet. Important concept to grab here is you can store data on your computer, inside your smartphone, on a memory card, on your hard disk, but what if your device gets damaged or gets stolen, or you are not at home and you need to access your computer for your stored data, or your phone is lost and your data is gone? But when you store your data on a cloud platform like Google Drive or Dropbox, you can access your data from any device and from any place, anywhere, by just logging into your account, same like a Facebook or Instagram account. What is cloud computing? Cloud computing is the delivery of on-demand computing services over the internet on a pay-as-you-go services, or in some cases free of cost. Cloud computing is on-demand facility of computer system resources, especially data storage and computing power and other IT resources through the internet. Cloud computing provides a solution for IT infrastructure at a very low price to businesses. Cloud also refers to manipulating, configuring, and accessing the hardware and software resources remotely. Cloud computing can be defined as delivering computing resources over an internet-based platform, over an internet-based network, rather than physically having the computing resources at the customer's or user's location. Means there exist certain cloud service providers which provide certain facilities, IT-based facilities, to the user over the internet, and the user is just sitting inside his home and he can access all the resources over the platform of internet provided by certain cloud provider companies. The cloud service providers allow the users to access, store, save, retrieve, or manage their data by using their cloud platforms or cloud resources. User doesn't need to use his own local hard disk or storage space or any other resource of his own computer. Wherever he goes, he can access his data over the internet. If the user wants to give access to his data to somebody else or wants to share his data with somebody else through that cloud platform, that is totally possible. The data can be anything such as files, images, documents, videos, any audio file, and much more. Cloud platforms or cloud services allow the users to store, backup their data for recovery. They allow the delivery of software services on demand. They allow the user to develop apps, websites, any such services or products using the cloud platforms too. Sometimes there are certain companies who build or buy this cloud infrastructure based on servers, data storage spaces, technical staff relevant to these services or in order to maintain these services and technical infrastructure, as well as some building to house these devices, cables or wires connecting them, routers or modems of high bandwidth. And these companies then rent their infrastructure to some other organizations for use on payment, as those organizations don't have enough money to build their own cloud infrastructure for their use. In some cases, these cloud providers don't send you the infrastructure, but just they don't just rent you the infrastructure, but just rent you the services being provided by that cloud-based platform. For example, a cloud provider sends or rents an organization the usage of a video conferencing based software and some storage and allots some storage space to record and store those meetings or conferences. For example, Google allows educational institutions to use its Google Zoom software online, which is a cloud-based software, in order to conduct online meetings and record these meeting sessions. The organizations or a person can rent this facility on minimal cost, or in some cases can use this facility without any charges. Actually, these cloud service providers take care of users' stored data. They take care of all the issues like security, maintenance, underlying infrastructure, backup of the user's data, etc., etc. So the user needs only to focus on his work and doesn't need to bother about or worry about these issues. A very generic cloud hierarchy looks something like that at cloud server's end. There exists infrastructure based on servers and other stuff like cables, storage devices, routers, interconnected and housed in a location, and many users around the world can access the resources or services or platform offered by cloud service providers to get their work done or in order to satisfy the different purposes. But remember that the user has nothing to do with this infrastructure's maintenance. Just he has to do is to utilize the services offered by the cloud provider and to pay for the continuity or subscription of those services, or maybe in some cases free of cost. Infrastructure behind the scenes or over the cloud is totally invisible to the user. User doesn't have any idea about the devices or operability or functionality or functioning of the cloud platform infrastructure or cloud platform architecture. The architecture of cloud computing is broadly divided into two parts: front end and back end. Both ends are connected through a network, normally an internet connection. The diagram in front of your eyes illustrates the cloud computing architecture's visual view. Front end associates with the user. This end is totally dedicated to the user. Front end is the view that is visible to the client or a user. It is the user part of cloud computing system. Front end contains user interface, options or icons based interface of some app, of some software, or of some cloud-based platform or service, or interface or window of user's web browser like Google Chrome's interface. which means that at the front end, in front of users' eyes, actually lie certain things like a web browser, internet connection, and the services or platform provided by the cloud service provider. While the back end is the cloud itself. It contains all the resources that are required to provide a cloud computing service. Backend is composed of infrastructure such as huge data storage spaces, server computers, routers, security mechanisms, service models and deployment models, which we will later on in this lecture we will study about that, along with technical staff to manage the infrastructure. So the back end is totally invisible to the user. User has actually nothing to do with the back end. Back end is totally dedicated to the cloud service provider. Cloud service provider actually has a concern with the back end. There are certain services and models working behind the scene, making the cloud computing feasible and accessible to end users. Our next objective is to discuss the working models for cloud computing, which are deployment models, service models. First of all, we will discuss the deployment model, which mainly consists of public clouds, private clouds, and hybrid clouds. Let's take an example in order to understand the concept of private, public, and hybrid clouds. Consider different type of vehicles people use for traveling from one place to another. If you want to travel through a public bus which is accessible to everyone along with you, you have to pay for the seat you occupy and you have to pay for the duration of the journey. If you travel 1 kilometer through bus, payment would be less, but if you travel 10 kilometers through bus, cost would be relatively higher. Similar kind of thing happens in a public cloud. You have to pay for the resources you use and for the time till you use those resources or cloud-based services, but along with other people, along with other users. More you use, more you pay. But important point is you share those resources simultaneously with other people. Private cloud, on the other hand, is like buying your own car and using it for your personal purposes. Now you are the owner of your car, so you can use it individually or solely. Once you bought it, you don't need to pay for it again and again. But yes, for its maintenance and fuel, you are responsible. Last type of a deployment model is hybrid cloud. This cloud can serve as a combination of a bus as well as a personal car. Means it's like a rented taxi where a user doesn't need to share a transport facility with other users as well as doesn't need to spend money on maintenance and fuel all by himself like a personal car. User just rents a taxi for individual use for a specific time duration. He can have the best of both. Means a person using hybrid cloud can have access to a cloud providing the services of both private and public clouds. Public cloud services are made available to the general public over the internet. A company or cloud provider provides its services to general public on commercial basis or for business purposes or for earning the profit. Public cloud can be less secure because of its availability and openness to every user, to general public. For example, Google's Gmail or Yahoo Mail, social networking sites like Facebook, Instagram, Twitter, WhatsApp, or Microsoft platforms, etc. They are public clouds. Private clouds belong to a particular company which manages its operations and maintenance, or private cloud provides services to a specific or particular organization, for example to a bank. Private cloud allows systems and services to be accessible within an organization only. It is private to that organization only. It is more secured because of its private nature. For example, Amazon Web Services or VMware, they actually provide private cloud services to different organizations around the globe. Third one is hybrid cloud. Hybrid cloud is a combination of public and private cloud in which the critical activities or confidential activities are performed using private cloud while the non-critical activities are performed using the public cloud. For example, federal agencies opt for private clouds when sensitive information is involved. Also, they use the public clouds to share datasets with public or other government departments. Our next objective is to discuss about the service models of cloud computing. Cloud computing offers three types of service models, which are SaaS, PaaS, and ES. SaaS stands for Software as a Service. PaaS stands for Platform as a Service. And ES stands for Infrastructure as a Service. SaaS, Software as a Service, is a software distributed model provided by cloud providers in which apps or applications or softwares or programs are hosted by the cloud service providers and made available to the customers or users over the internet. These softwares can be made available on purchase or either free of cost. SaaS model provides softwares on demand over online platform. Second type of service model is PaaS, Platform as a Service. Cloud service providers provide a platform and environment to allow developers to build applications, services, or products to develop anything from a website to a giant operating system. This service is actually hosted by the cloud provider and accessed by the users through internet. To understand it in simple terms, let's compare this with painting a picture, where college provides you with paint colors, paint brushes, and paper, and you just have to draw a beautiful picture using these tools. So, PaaS cloud model provides the user with these type of tools and its platform to empower the user to develop or invent or innovate something. But remember that user has no control over the underlying architecture, over the underlying infrastructure. User is just using the resources provided by the cloud service provider in order to develop some product. A PaaS cloud provider provides the user with platform and tools to develop or create something such as a website using WordPress cloud service, which is an online platform or to let user develop a website. Third type of service model is ES, Infrastructure as a Service. Cloud service providers provide this service model in order to let the user access the hardware, servers, storage space of its cloud platform, not physically by going there on that location where these infrastructural things are placed, but by accessing these underlying resources virtually or electronically. Usually, infrastructure as a service by the cloud provider is used by small businesses who can't afford to establish or buy their own infrastructure, such as expensive mainframe computers as servers or large storage hard disks or high bandwidth routers, etc., as annually a huge amount would be required to maintain and upgrade these hardware components. So a small business can save this cost by using ES provided by a cloud provider. If we talk about the famous cloud service providers around the world, they would be Amazon Web Services, Microsoft, IBM Cloud, VMware, Google Cloud Platform, DigitalOcean, Terramark, and many more. SaaS stands for Software as a Service. PaaS stands for Platform as a Service, and ES stands for Infrastructure as a Service. SaaS, Software as a Service, is a software distributed model provided by cloud providers in which apps, Our applications or softwares or programs are hosted by the cloud service providers and made available to the customers or users over the internet. These softwares can be made available on purchase or either free of cost. SaaS model provides softwares on demand over online platform. Second type of service model is PaaS, platform as a service. Cloud service providers provide a platform and environment to allow developers to build applications, services, or products to develop anything from a website to a giant operating system. This service is actually hosted by the cloud provider and accessed by the users through internet. To understand it in simple terms, let's compare this with painting a picture, where college provides you with paint colors, paint brushes and paper, and you just have to draw a beautiful picture using these tools. So, PaaS cloud model provides the user with these type of tools and its platform to empower the user to develop or invent or innovate something. But remember that user has no control over the underlying architecture, over the underlying infrastructure. User is just using the resources provided by the cloud service provider in order to develop some product. A PaaS cloud provider provides a user with platform and tools to develop or create something such as a website using WordPress cloud service, which is an online platform or to let user develop a website. Third type of service model is IaaS, infrastructure as a service. Cloud service providers provide this service model in order to let the user access the hardware, servers, storage space of its cloud platform, not physically by going there on that location where these infrastructural things are placed, but by accessing these underlying resources virtually or electronically. Usually, infrastructure as a service by the cloud provider is used by small businesses who can't afford to establish or buy their own infrastructure, such as expensive mainframe computers as servers or large storage hard disks or high bandwidth routers, etc., as annually a huge amount would be required to maintain and upgrade these hardware components. So a small business can save this cost by using IaaS provided by a cloud provider. If we talk about the famous cloud service providers around the world, they would be Amazon Web Services, Microsoft, IBM Cloud, VMware, Google Cloud Platform, DigitalOcean, Terramark, and many more. So now we are done with the overview or introduction of cloud computing. We have actually studied the deployment models and service models of cloud computing. Now we will move towards the discussion about the advantages of cloud computing. Advantages or benefits of cloud computing. It has certain advantages. It provides the facility of device and location independence. It provides the facility of sharing information. It provides the facility of automatic updates, multi-sharing, connecting dispersed groups. It provides the facility of scalability and maintenance by the cloud service providers. It provides the facility of being available 24/7. It provides the facility of improved mobility, backup and recovery. It is cost effective, and it provides a user with on-demand services, and it also has a resource pool. First advantage is of sharing information. If your data is stored on a cloud platform like Google Drive or Google Dropbox, you can share your huge amounts of data with anyone. Suppose you are working on a project and you want to share the project details with your friend. So you can do that by sitting anywhere around the globe. Second advantage is of device and location independence. You can store your data or access your data from anywhere, from any device. Cloud apps enable the users to access system using a web browser or internet regardless of their location and the type of device they are using. Third advantage of cloud computing is automatic software updates. Cloud-based softwares or apps are updated automatically by the cloud providers. A user doesn't need to update his software. User just has to click the updates option. Rest is done by the cloud provider. These updates or upgrades basically add new features to the cloud-based apps or softwares. Fourth advantage is efficiency and multi-sharing. Cloud computing allows multiple users to share or use the cloud resources or apps or programs simultaneously at the same time, sharing common infrastructure. For example, a website over the internet can be used by multiple users at the same time or simultaneously. Fifth advantage of cloud computing is better reach, or it connects dispersed groups. It connects different people around the world on a platform, for example, social media platform, where people around the world are connected with one another by sitting in different cities, by sitting in different countries. In organizations, staff members can stay connected using cloud-based platforms by sitting in different cities, by sitting in different homes, by sitting in different areas, working on one same project. Sixth advantage is of scalability or rapid elasticity. In cloud computing, scaling or extension of resources or extension of infrastructure is easy. Scaling of resources means the capacity of a cloud-based resource to deal with increasing or decreasing demands of the user. For example, Google Drive storage got extended with the passage of time as its users got increased. Seventh advantage is of reliability. Cloud services are always available to the user round the clock, 24/7. Moreover, users' data is saved by the cloud providers at multiple places. There is no loss of data. Even if the data is lost, that data can be recovered through its backup copy. The chances of infrastructural failures are minimum. Eighth advantage of cloud computing is improved mobility. Cloud-based services or platforms are accessible from anywhere, whichever location you travel, or to whichever city you travel or move around the world. You can access your data, you can access your apps or programs or softwares provided or stored on a cloud-based platform. Ninth advantage of cloud computing is backup and recovery. It is secured in terms it offers a data backup and recovery facility. In case of any data loss, the data of the user can be recovered using the backup copies. Another advantage of cloud computing is that it is cost effective. For users, it's a cost effective solution as the user doesn't need to purchase a storage space for storing data or a CPU for execution. Every resource needed by the user is provided by the cloud service provider over the cloud platform. User can use these resources without buying them on a heavy budget. Maintenance of cloud platforms or cloud infrastructure providing cloud services is the headache of cloud service providers. User just uses the services and user has no concern with the maintenance of the infrastructure. So the maintenance cost is also not the headache of the user. Another advantage of cloud computing is that it provides on-demand self-services. User can access applications or softwares as utilities over the internet. That user can manipulate and configure these services or resources online at any time. Cloud computing offers online development and deployment tools for development of some products through PaaS model. Cloud services can be used without interaction with cloud service provider. Cloud computing permits users to use web services and resources on demand by sitting anywhere in the world. Another advantage, very important advantage, is of resource pooling. Resource pooling is similar to multi-sharing the resources provided by a cloud service provider. In cloud computing, resource pooling means allowing multiple customers or users to share a common pool of resources among themselves. Of course, if something has certain pros or advantages, must have certain cons or disadvantages too, as there are two sides of a coin. So, cloud computing has certain disadvantages too, which are relevant to security and privacy and related to its vulnerability to attacks. Number one, security and privacy. It is the biggest concern about cloud computing since data management and infrastructure management in cloud is provided by a cloud provider. It can be a risk to hand over the sensitive or confidential information to cloud service providers in case they don't have proper security layers applied on their infrastructure and platform. In that case, your confidential data can be exposed to hackers. For example, if a bank is storing its customers' data, ATM PIN cards or credit cards PIN codes, or customers' accounts details, etc. on a cloud platform on a private cloud, and proper security layers are not applied on cloud's server computer, hackers can hack or can steal all these confidential PIN codes by hacking the cloud platforms of that bank and can withdraw or use customers' money. Second risk related to the cloud computing is internet interface compromise or vulnerability to attacks. As cloud services can be accessed through internet, if a hacker hacks your internet connection or modem or router, that hacker can easily trace or steal your data you are storing or managing on a cloud platform. That hacker can easily trace or steal the data coming in or coming out of your network, for example, your emails, etc. That way your interface can be compromised. Cloud computing is on-demand delivery of IT resources through internet, either on payment or free of cost service to the user. User can use these resources online instead of buying, owning and maintaining physical data centers having servers, hard disks, RAMs or routers. You can access technology services such as CPUs, computing power, data storage, information or record saving and databases on as-needed basis from a cloud provider like Amazon, Google, Microsoft or Yahoo and lots more. Organizations of every type, size and industry can use cloud platform for a wide variety of uses such as for data backup, disaster recovery, email, for storage of data for software development, product development and testing, big data analytics using platform as a service or PaaS cloud model. Organizations or employees or general public can also use SaaS platform for using cloud-based apps or software. For example, healthcare companies are using the PaaS cloud model to develop more personalized apps for patients, treatments, etc. For example, telehealthcare systems developed in this coronavirus pandemic. Financial services or companies providing these services like banks are using clouds to power real-time fraud detections and preventions. Video games makers are using the cloud to deliver online games to millions of players online, for example, Ludo Star or PUBG around the world. With cloud computing, your business can become more agile, reduce infrastructural costs, instantly scale and deploy globally in minutes, can reach to customers immediately using EaaS model. Cloud computing gives instant access to a broad range of technologies so that you can innovate faster, build nearly anything you can imagine by using PaaS model and allows to compute, store using SaaS model accessing the cloud servers. You can implement your ideas in a matter of minutes. Cloud apps give you the platform to test new ideas, to experiment, to test your ideas. For example, if you want to develop a website, test and experiment that website. You don't need to make investments or buy hardware or software needed for developing a website. You can use PaaS cloud service for free, or in some cases only pay for it as you consume its services. You can access cloud resources in real time or live. You can expand or maximize or scale up the use of these cloud resources if your demand increases. Cloud computing makes it easy for you to deploy or expand your businesses or products. For example, your website needs to be advertised around the globe. So your website, by using a cloud platform like Facebook or YouTube, can be expanded, can be advertised to new regions around the world within short span of time. For example, another example, through internet, a Facebook cloud platform enables its user to post an advertisement about a website or about an app or a software. That's why the developers of websites or apps would get noticed in a really short span of time around the world if people like and share those advertised stuff, those advertised websites or softwares or apps. If we talk about YouTube cloud platform, videos of random people get really popular on YouTube platform as people view, share and like those videos over the cloud platform of YouTube. You are even watching these recorded lectures on YouTube's cloud platform. So these videos get stored on YouTube's cloud storage space after getting posted. What is a data center? A data center is a facility composed of networked computers and storage that businesses and other organizations use to organize, process, store, and disseminate large amounts of data. Means a data center is a building, dedicated space within a building or a group of buildings used to house computer systems, associated servers with thousands of CPUs installed inside them, or components such as large capacity hard disks, RAMs, backup storage spaces, high bandwidth, fast speed routers for internet, infrastructure for power supply, air conditioning to control heat produced by machinery, fire protection, various security devices, technical staff to manage the equipment. A data center is an industrial scale operation using as much as electricity as a small town. For example, take an example of Google's data center. Trillions of users around the world use Google for searching something, some data, some information, some website, some movie or drama, some personality, some book, some notes, etc., etc. Did you ever think that whatever you search or whatever thing you search on Google, where does it get the answer from? How does it produces the result? How come Google knows everything? Fact is, in a Google data center, hundreds or thousands of server computers, mainframe computers, are installed. On these servers, each and every type of data, information about every subject, every topic, every movie, drama, song, or personalities is pre-stored. So when a user types or searches a keyword relevant to any topic, it automatically links websites or web pages and information regarding those topics, makes available every possible information installed on its servers to the user. If user wants to store some data on Google Drive or an email inside his Gmail account in Google's data center, there exist hundreds and thousands of storage hard disks with billions of terabyte storage space. So billions of users around the world can store their email inbox or send items data in those servers. To execute or process users' data, every server has thousands of CPUs or microprocessors installed inside it. So if a data center has thousands of servers housed inside a data center building, just multiply thousands with thousands. Thousands of servers, hard disks, routers, and IT-based devices are interconnected inside a data center building. Data centers serve as the principal repositories for all manner of IT equipment, including servers, storage subsystems, networking switches, routers, and firewalls, as well as cabling and physical racks used to organize and interconnect the IT equipment. A data center must also contain an adequate infrastructure such as power distribution and supplemental power systems, subsystems. This also includes electrical switching, uninterruptible power supplies, backup generators, ventilation, and data center cooling systems such as air conditioners, etc. Data centers can be owned by cloud service providers who provide cloud services over internet to businesses and to common users. Data centers are simply centralized locations where computing and networking equipment is concentrated for the purpose of collecting, storing, processing, distributing, or allowing access to large amounts of data. In Pakistan, PTCL and several universities like NUST and ComSet, several software companies have their own data centers. In Abbottabad, ComSet University's data center resides on Chinar Road. Someday, inshallah, we will be visiting that data center.
A data center is the brains of the internet, the engine of the internet.
It is a giant building with a lot of power, a lot of cooling, and a lot of computers.
Row upon row upon row of machines, all working together to provide the services that make Google function.
I love building and operating data centers. I'm Joe Cava, Vice President of Data Centers at Google. I'm responsible for managing the teams globally that design, build, and operate Google's data centers. We're also responsible for the environmental health and safety, sustainability, and carbon offsets for our data centers. This data center here in South Carolina is one node in a larger network of data centers all over the world. Of all the employees at Google, a very, very small percentage of those employees are authorized to even enter a data center campus. The men and women that run these data centers and keep them up 24 hours a day, 7 days a week, they are incredibly passionate about what they're doing.
In layman's terms, what do I do?
I typically refer to myself as the herder of cats.
I'm an engineer, hardware site operator. We keep the lights on, and we enjoy doing it.
And they work very hard. So we like to provide them a fun environment where they can also play hard as well.
We just went past the 3 million man-hour mark for zero lost time incidents. 3 million man-hours is a really long time, and with the number of people that we have on site, that is an amazing accomplishment.
I think the Google data centers really can offer a level of security that almost no other company can match. We have a information security team that is truly second to none. You have the expression, they wrote the book on that. Well, there are many of our information security team members that have really written the books on best practices in information security. Protecting the security and the privacy of our users' information is our foremost design criteria. We use various layers of higher level security the closer into the center of the campus you get. So just to enter this campus, my badge had to be on a pre-authorized access list. Then to come into the building, that was another level of security. To get into the secure corridor, which leads to the data center, that's a higher level of security. And the data center and the networking rooms are the highest level of security. And the technologies we use are different. Like for instance, in our highest level areas, we even use underfloor intrusion detection via laser beams. So I'm going to demonstrate going into the secure corridor now. One, I have to be on the authorized list with my badge. And then two, I use a biometric iris scanner to verify that it truly is me. Okay, here we are on the data center floor. The first thing that I notice is that it's a little warm in here. It's about 80 degrees Fahrenheit. Google runs our data centers warmer than most because it helps with the efficiency. You'll notice that we have overhead power distribution.
Coming from the outside yard, we bring in the high voltage power, distribute across the bus bars to all of the customized bus taps that are basically plugs where we plug in all the extension cords. All of our racks don't really look like a traditional server rack. These are custom designed and built for Google so that we can optimize the servers for hyper efficiency and high performance computing. It's true that sometimes drives fail and we have to replace them to upgrade them because maybe they're just no longer efficient to run. We have a very thorough end-to-end chain of custody process for managing those drives from the time that they're checked out to the server till they're brought to an ultra-secure cage where they're erased and crushed if necessary. So any drive that can't be verified as 100% clean, we crush it first, and then we take it to an industrial wood chipper where it's shredded into these little pieces like this.
In the time that I've been at Google for almost 6.5 years now, we have changed our cooling technologies at least 5 times.
Most data centers have air conditioning units along the perimeter walls that force cold air under the floor that then raises up in front of the servers and cools the servers. In our solution, we take the server racks and we put it right up against our air conditioning unit. We just use cool water flowing through those copper coils that you see there. So the hot air from the servers is contained in that hot aisle. It raises up, passes across those coils, where the heat from the air transfers to the water in those coils, and then that warm water is then brought outside the data center to our cooling plant, where it is cooled down through our cooling towers and returned back to the data center, and that process just repeats over and over again.
To me, the thing that amazes me about Google and the data centers is the pace of innovation and always challenging the way we're doing things. So when people say that innovation in a certain area is done, that we've kind of reached the pinnacle of what can be achieved, I just laugh.
Dear students, now we are done with our today's lecture, in which we have studied 2 modern uses of computers, that is, cloud computing and the concept of data centers. From this week and onwards, you would attempt some assignments and would get involved in some activities. Your first activity to perform would be that you have to install any cloud-based app, either on your smartphone or on your laptop. I would suggest that install Google Zoom, which is a cloud facility we would be using soon. Moreover, you would have to make an assignment, a written assignment on cloud computing of 8 marks. It's a long question basically. Concepts you would need to cover would be its basic definitions, its services and service models and deployment models, its service providers, its advantages as well as disadvantages. Of course, that would be totally up to you, that how would you briefly compress or summarize a long lecture into 8 marks long note. That would definitely show your writing skills or question attention techniques. You would upload these assignments on your portal. You would attempt the assignment on pages. You can take snapshots, make a file, and then you can upload it on the portal. Remember that you would be able to create your content, your data and diagrams for the assignment by listening to this lecture. Dear students, best of luck for your assignment. You can submit your assignment till next Tuesday. May Allah bless you. Stay safe, stay healthy. Allah Hafiz, and thank you.